can go ahead and get started. We can go ahead and get started with a couple introductions. My name's Gary Henderson. I'm the Director of Engineering Executive Education. One of the things our office manages is the professional degree programs, also known as the Master of Advanced Studies program. Left, you'll see Yvonne and Stacy. I'm sure many of you may have already spoken with either Yvonne or Stacy, and you'll note from this presentation they are really your go-to people to ask questions about the programs. Not only will they help applicants and prospective students, but they also manage the programs throughout the duration. So they really are experts and can connect you with the resources to make informed decisions on the program that you're interested in. We're also joined by Kristen and Samantha, both on the team as well. And those of you who join us starting in the fall will surely get to know Kristen and Samantha quite well throughout the program. And just as some background information, I'm sure you're all somewhat familiar with the UC San Diego Jacobs School of Engineering, largest in California among public universities, ranked 10th in the nation. Distinguished faculty over 275. I'm sure that number is a little small now. So it's larger than that, but a very research-intensive academic institution that's committed to serving the needs of industry as well, with the latest in research and education. If rankings are important to you in your decision making, I put some here to several of our other rankings that you can delve into at your leisure. And these Master of Advanced Studies programs are professional degree programs that are really born out of partnerships and collaborations across the campus, not only within departments within the Jacobs School of Engineering, but also other units and schools within the campus and more broadly, actually. And so I put a couple here of our key partners for these 3 degree programs, the San Diego Supercomputer, Brady School of Management, as well as the Qualcomm Institute. And those partnerships also span industry lines. So all of our faculty and these programs in particular are really focused on working professionals and the right mix of skills that can expose you to areas that will reap rewards in your professional career, and really designed to give you several years of practical experience that would take you many years to amass just through your day-to-day job and learning. And with more than 200 companies represented among our alumni, that part. So oftentimes we get the question, what is a Master of Advanced Studies? The easiest way to talk about this is in terms of what's required of students. It is a master's degree conferred by the UC San Diego, just like every other graduate degree on campus. But they are unique in that they're designed for engineering and technical professionals. And they're unique in the sense, maybe not so much unique as focused on interdisciplinary or even multidisciplinary programs focused on emerging areas and new fields that some of our traditional programs don't address as fully as needed by working professionals. Currently, we have these 3 programs. I assume you know what these programs are, given your interest in one or more of them. They're the Architecture-Based Enterprise Systems Engineering since 2010, Wireless Embedded Systems since 2011, and Data Science and Engineering 2014, notably the first data science program approved at UC San Diego. And we do have more in development that we hope to share in the coming months. As far as our program design, again, they're graduate degrees explicitly focused to meet the needs of engineering and technical professionals and to address skills that are most needed now. And I think every faculty director would agree that these are continuously developed over time as things change and things come in and out of focus. And honestly, after every course, if not after every program run, you're looking to continuously improve and ensure that our degree programs remain relevant, and that our companies support students because they help and they help a lot. And how they do that is by developing or delivering integrated interdisciplinary knowledge. We have a structure, an approach optimized for working professionals that can't necessarily just quit their job and come to campus for a full-time course of study. The cohort design is an important aspect, as is project-based learning in each of our degree programs. And so you'll get to know and have access to an expansive network, not just from college, schools, but also your network of peers. So the current students in the program, as well as ours. So in our specific discussions about each program, we'll go into this a bit more in depth. These are just some general admissions guidelines. And what I should mention here is the admissions committee is comprised of the faculty members charge of these programs is really about fit. And are you capable of succeeding in this program based on your background and your professional experience? And are you at a place in your position or looking to get to that place in your position where these programs would really add value for you? So I'll mention these as general admissions guidelines. There are always exceptions, as there always are. But I would really encourage you to reach out to Stacy and or Yvonne, and we can certainly set up time. And some of you may have already reached out to faculty directors to discuss this as well. But we really encourage you to do that. We'd like to give you a realistic preview of what you're getting into, so you know what you're getting into, and we're looking for every student that wants to join and is committed to succeeding to flourish in these programs. Again, this is just to give you a quick snapshot. We'll go into the actual schedule in more detail in just a few minutes here. The AESE is a one-year program. You'll see in parentheses full-time, but that doesn't mean it's a full-time schedule program. It's actually in the same flexible format as all of our programs, but it is accelerated. There's a 1 year, 4 quarters, as you'll see there. The WES program, the Wireless Embedded Systems, is a 2-year program, and you'll see that spans 2 years. Middle, and then the data science is also 2 years. The caveat that there are no summer courses. But we'll address those. The faculty will address program schedule detail, of course. Program costs. There's our per unit tuition fees. For each of the programs, based on the unit loads, it all comes out to around $40,000, and it includes all of your course materials, all of your software and hardware that you may need during the program, and parking and meals when you're on campus during class. And the only additional costs in this are UC graduate student fees. We put a link there on the bottom of this page. share these slides with all the participants shortly after this session, so you can take a look at that. And just for those of you that have not yet reviewed our website, I'd encourage you to do that. Our website has microsites inside for each program. So whether it's the faculty or the curriculum or the costs and the admissions process, all of that information is readily available to you through our website that's linked there. And again, I can't emphasize enough, if you're even considering applying, I would get in touch with Stacy and or Yvonne, depending on your program, as well as faculty directors. And we're happy to provide introductions to others, perhaps in your workplace, that have taken the program that you'd like to talk to, or that have similar roles or backgrounds. So stay in touch and feel free to reach out to us. That's why we're here. Fine. So yes, in the interest of time, we'll have a program-specific Q&A, but we'll ask that you hold your questions during this overview section so that we can get through it, and then we'll open up the breakout rooms and have a lively discussion with the faculty. Okay, and with that, we'll start with the Wireless Embedded Systems program, and I'll hand it over to faculty directors Ryan Kessner and Fred Harris. And we also have faculty member John Eldon in attendance with us as well. So take it away, Ryan.
All right, thank you. You can go to the next slide, please. So this is as all the programs are, is a interdisciplinary program. So this program is covering topics between sort of a traditional computer science department or a computer science master's degree and an electrical engineering master's degree. And so we're covering, really kind of nice core topics between both of those in a coherent way, we think. So we're looking for people that are interested in learning about sort of the next generation embedded computing systems, so GPUs and FPGAs and AI engines, and also understanding how to integrate those with all kinds of different wireless systems, 5G, LoRa, all the different wireless systems that are coming out in recent years. So it's a 2-year program, as was mentioned, and we have a really great slate of professors that teach all of these different courses that I'll get to here in a second. So next slide, please, Yvonne. So the motivation for this program over the past decade has been the phenomenal growth of computing devices and also the wireless connectivity of those devices. So it's an interesting thought exercise to think about how much you interact with wireless devices on a daily basis. So your phones, if you have a Find My in your Apple device, you're interacting with all of these different iPhones that you're sort of passing by in different points of the day. Projecting to Apple AirPlay or all kinds of different types of things that are just really core to embedded computing and wireless computing or wireless communications as well. So this is a trend that's going to continue. I don't think this is going to stop in a few years, and the program has really started and evolved over the years to reflect those trends in industry and also in research. Next slide, please. So the big challenge with all of these devices is really balancing and doing a lot of engineering to get them into the right place. So they're very diverse and have very different requirements depending on what you're doing, right? So if you're in a car and you're transmitting information to 5G in order to help your car learn better to where pedestrians are or cars are, like something like a company like Tesla might do. You have a lot of power and you have a lot of compute capability. But if you're on a smartphone, you have a lot less power and a lot less compute capability. And if you're in a refrigerator or if you're in a washing machine, you perhaps have even less. And if you're embedded in a sensor that's sitting out in the wilderness with just a battery connected to it, you have even far less compute power and energy to do all the things that you want to do. And all those devices have really interesting mixes of hardware and software and important trade-offs in terms of performance and energy consumption, power, and just so many interesting kind of topics that you need to learn, but also combine those topics into a coherent program, which is what we are doing in this wireless embedded systems program. So go to the next slide, Yvonne, please. So the program is trying to reflect that. So we have 9 different courses that are spread out over the couple of years. By and large, you take 1 course a quarter until that second year, and then you start taking a couple courses a quarter in that second year. So the first year is really focusing on giving you the fundamentals of what you need to build wireless embedded systems. So both on the software side, so programming these devices and understanding what new processors and how to build firmware, things like that. And then also on the sort of the electrical engineering side or the wireless communication side, doing the digital signal processing, building up more complex ways to communicate reliably over the air, and then building up 5G and beyond systems to actually understanding how those work and actually building and implementing those devices on GPUs, on FPGAs, on CPUs, and really sort of taking all these courses one by one, combining them, and then reaching at the end a really nice capstone where you develop all of your skills and show off all the things that you learned over the couple years. We'll go into a little bit more detail on that. So like I'd mentioned, that there are sort of a mix between electrical engineering and computer science, so digital signal processing, embedded systems is computer science, back to signal processing and electrical engineering, back to computer science, and getting that fundamentals of all of the things that you would expect to learn in a master's degree. And then moving those more specifically into how do you build systems with how do you build on the modern compute platforms? How do you build with emerging wireless communication protocols? And then culminating at the end of a class with a really nice capstone project where you pick your project out and you take some skills and ideas that you've learned throughout the couple years and implement something real that you can demonstrate and show off to your employers and your family and your friends and really anybody that wants to listen to you at that point. So next slide, please. So I'll hand it over to Iman to handle all the gory details, but Fred and John and I will be happy to hang out after the presentations are done and answer any of your questions.
Thank you, Ryan. Definitely not gory details, just basic admissions guidelines that I'm going to briefly go over. It's pretty straightforward. I think our previous slides may have touched on it briefly. We're looking for bachelor's degrees in engineering, science, physics, or math, etc. It's a preference. It's definitely not a requirement. We do have a variety of other backgrounds that have applied for the program and that have gotten in. So definitely do not let that discourage you. The 3.0 minimum GPA is a university requirement. However, we have worked with graduate division to work around that. If you have something a little bit lower, it just all depends case by case. So definitely do not hesitate to reach out to me if you have any concerns about that. A statement of purpose, 3 letters of recommendation are required for the West program, a resume, and we do not require the GRE. Again, these are basic guidelines. If you have any questions regarding any of them, do not hesitate to reach out. And now we will go on to our next program, which is the Architecture-Based Enterprise Systems Engineering Leadership Program. And I will introduce our faculty director, John Wade, to go over that program.
Thank you, Yvonne. Hi, everyone. I'd like to talk to you about the, we call it AESE, Architecture-Based Enterprise Systems Engineering Leadership Program. So this is really a program that's a partnership between the Jacobs School of Engineering and the Rady School of Management. Leadership is a big part of what we do. And particularly, we're housed in the Mechanical and Aerospace Engineering Department of the Jacobs School, but we really work and take much from the other departments as well. we are focused on engineers who have 5 years of relevant professional experience, who are in a position to basically grow with respect to their leadership and their impact within their organization. Although Stacy will talk about it in more detail, you know, it's not a hard and fast rule, but we do want students who have had some professional experience and feel comfortable in that. As mentioned, it's a one-year program. So you'll be starting in September 2023, and you'll be completing it at the end of August 2024. As is the case with the other programs, you'll be working on alternating Fridays and Saturdays. And then there's a 1 4-day workshop per quarter. Next slide, please. So what do we, why are we doing this? What sort of drove this program? And if you look at the, the industrial revolutions we've gone through, the first being sort of steam power, and then industry 2.0, mass production, and then 3.0 with computation. Really in 4.0, where it's a cyber physical world, Internet of Things, as was spoken about the other programs, it's a place where we're really talking about interconnections of things. Systems engineering really started with mechanical systems with electrical elements, moving to systems with computations, with islands of software, and then have moved into sort of software intensive systems, and then network intensive systems where things are interconnected and resources and data is sort of shared, throughout the network. And then moving on to enterprise systems where the organizational governance can be decentralized. And it's really when you get to this perspective that things become much, much more challenging, in the sense that you don't have a specific hard and fast problem that you're trying to solve, but actually something that involves more of a systems thinking approach where you have to look at multiple perspectives. Next slide, please. And so we're in a transition in systems thinking, and you can sort of click through these as you see fit. Moving from systems that were sort of built to last, systems that are built to evolve, from opinion-based decision-making to model and data-driven decision-making, from paper-based documentation, model-based documents, deeply integrated architectures to modularized architectures, from hierarchical organizations to ecosystems of partners, from satisfying requirements to constant experimentation and innovation, phase-based verification validation to continuous verification validation, and separated development and operations to the place now where actually operations, development become more and more merged over time. So it's a very different world that we're working in today than we were just 10, 15 years ago. Next slide, please. And so a lot of this is being driven by the power of digitalization, which is really about extracting value from data. And data can come in many forms. It can come from observed data that we actually see, or it can come from simulated data, or both. Experiments can actually be run in both places. It can be run in the observed world or in the simulated world. And the key there is that you're able to look at the simulated world and the observed world and use the observed data to sort of verify the simulated data that you've created, the simulated world. But the point of all this is really to enable you to observe, to orient, to decide, and act more quickly. And so this is the OODA loop. And the Internet of Things has been mentioned as ability to collect data from many different sources. Machine learning helps you to sort of orient along with, understanding your context. And artificial intelligence can help you decide. And then DevOps, development operations, can help you act more quickly. And it's really being able to get through this cycle quickly and efficiently that determines, how competitive we'll be with respect to our organizations, our products and services. Next slide, please. And so this is really what the architecture-based enterprise systems engineering program is all about, is how do we navigate that world of data and digitalization and digitized decision-making? And again, this is a partnership between the Rady School of Management and the Jacobs School of Engineering. Next slide. And so we focus on the integration of things that were previously unconnected, and how do they interoperate to accomplish things that may not have been possible in the past. And so, looking at the systems of systems, there's server farms, there's the internet, there's digital capabilities, mobile devices, the Internet of Things, the cloud and big data, and increasingly AI and machine learning. And we embrace all of those things. Next slide, please. And so our curriculum consists of sort of 4 major segments. The first segment in the fall is about systems thinking. We're looking at leadership. And so this is a course that's focused entirely on leadership, on teamship, on your individual capabilities, on the things that are important to you, your strengths and weaknesses, and how they work in your leadership style and how you work with others. There's goals and strategy. There's finance and accounting, the business side of things, complex systems thinking, agile development, and DevOps. So it really sets the overall framework in context of, what is a system that you're working on. And many students will form cohorts within their organization, and they'll look at what are the challenging enterprise level challenges that we have within our organization. What does that problem look like, and how do we go about resolving those? In the winter, we look at systems development. So there's enterprise architectures, architectural frameworks, use cases, capabilities, service-oriented architectures, enterprise. We talk about cybersecurity, we talk about physical architectures, and so on and so forth. In the spring, we get into decision systems. So what are the measures of performance, the measures of effectiveness? What are the types of architectures we may be dealing with? What's the art of decision making? We go into data analytics, big data, deep learning, investment valuation, and managing stakeholder relationships. And then in the summer, we pull it all together. And this is all pulled together, with your projects, using SysML, using data analytic tools, cybersecurity tools, and so on and so forth. And so that's the overall sequence. And it's really building upon each of these. Should say that the project that you work on is threaded through all these. So although it's a capstone project in many senses, it's a keystone project, and that everything you learn in each of the courses is immediately applied to the project. And so the project threads through all this and pulls it all together and really integrates all the topics of learning that you get in each of these courses. Next slide, please. Our model of learning is one where the classroom and what you hear in lectures is really a small part of it. So generally, we'll have some lectures in the classroom, and then teams will break up and we'll be doing active learning within the course itself. And we'll provide mentoring and coaching throughout that process. On-the-job experience in this case is actually the teamwork that you do outside of the classroom. And we're available as faculty members, as instructors throughout that process. But it's really the work that you're doing on your project that enables you to gain the skills you need to get proficient, and also provides the means to immediately apply what you're learning on the job. Also, as this is a program that is relates between the business side of things and the engineering side of things, there's a lot of leadership types of skills and other skills that our students have applied immediately on the job. Often hear from the students, when they come back after the completed course, saying, "Hey, I tried and used several of the things that we talked about just last week, in course," and we can give feedback and we can help coach through that as well. Next slide, please. So, developing our system thinking capabilities comes in many ways and shapes and forms. So understanding the overall enterprise landscape, involving and interacting with enterprise stakeholders. This is your excuse to talk to people in your organization at many levels, up and down the managerial ranks and throughout the sort of engineering side of things, to help you understand the challenges and the problems that are faced in the enterprise. You're defining goals and missions. You're identifying the desired capabilities that you actually want to create at the enterprise, develop architectural models to support them, and then iterate, based on experimentation and experience. And we find that the people who go through this program have their careers accelerated with respect to leadership and team building, and those who want to get more into the managerial side of things. Next slide. So our delivery, again, it's a one-year program. Classes are on the Fridays and Saturdays. There's one Wednesday through Saturday workshop per quarter. Classes are from 9 o'clock till 6. Breakfast and lunch is provided. The classes are offered sequentially. So although you have 3 classes in a quarter, it isn't like you're taking all 3 classes at the same time. You take the first course, followed by the next course and the next course, and they build upon on each other. There's 2-day team project meetings per quarter as well that sort of ties it together. So there's 32 in-class contact hours, 8 hours times 4 days. There's a final 4-day team project capstone class that happens at the end of August where we pull this together, and you'll be presenting, your projects to folks in your organization and across organizations, and sometimes, quite often, we'll have executives within the organizations, that will listen to these projects and provide feedback. Next slide. Stacy, take it away.
Thank you, John. So my name's Stacy. I'm the program manager for the AESE program. Similar to the other 2 programs, these are admissions guidelines. They are not hard and fast requirements. Because this is an engineering degree, we typically like to see a bachelor's degree in some sort of technical field. However, we have had applicants successfully apply to and make their way through the program with a degree that is not in a STEM field. So please do keep that in mind. 3.0 minimum undergraduate GPA is a university requirement, but we can write a letter of exception for that if you graduated with something slightly under that. And we have found that GPA is a little bit less critical if you have had a bit of work experience and you state that in your resume. We need a descriptive statement of purpose. So what do you want to get out of the program, and what sort of perspectives can you bring to the cohort? At least 2 letters of recommendation. A lot of students do submit 3, and those letters should come from a colleague in some sort of supervisory position. Again, the 5 years of relevant work experience is something that we look for, but we do give a holistic review to your application. So if you're under that, please know that that's not going to be an automatic disqualification. An informative resume is good, and we do not require a GRE for this program. Next slide. And I'd like to introduce Dr. Ilkay Alcintas and Dr. Aline Deutsch. I'm not sure if he's here this time, but I believe Dr. Ilkay Alcintas will present on the GSE program.
Good evening, and thank you, Stacy. Yeah, I'll present the Data Science and Engineering program. This program is a collaboration between Computer Science and Engineering and San Diego Supercomputer Center, so it's jointly run. And the main audience of our program is professionals with a background in a related discipline like computer science or engineering or math, with an interest in data analysis. So like other programs, it's a 2-year program. And for this cohort, the classes will start September 2023 and run through June 2025. So our objective in this program is to combine the skills that you're bringing in with new ones, make it programming, database management, or statistical skills, to apply them to this new field of data science, and to build models of data, maybe in ways that identifying, analyzing trends and doing predictive modeling and analysis. And I think these days, if you're here for data science, it requires not much of an introduction, and often you get references to it, referred to as AI, right? Artificial intelligence is definitely a part of the picture here. Next, please. So data science, why are we talking about it? Because data we are generating is actually quite substantial, and it's been referred to as big data. Big data is defined by not just this volume like you're seeing here, but also some characteristics of these. It's highly variable. It comes from many different sources, so it has high complexity. And it's also hard to manage in terms of ingestion of data based on its speed, which we refer to as the velocity, and organization of it, along with related to many forms of data sources and that variety. There are some quality issues or accuracy issues with data that is a part of big data management and analysis. So that's what we refer to as another V, veracity. But the idea is when you go through all that and create a data science process to analyze big data, in many areas we are seeing high value, yet another V. Thanks, please. And how does data science help with that? I think it's one of the disciplines that are emerging around this massive data sets and at scale, the need to use data at scale within many disciplines, business areas, and domains. This diagram actually is a pretty popular one to explain a data scientist, what kind of skills a data scientist brings. It's a combination of, when you look at the intersection of all three, it's a combination of math and statistics knowledge, hacking skills, including data management, and also some form of domain expertise. So, and domain expertise, it could be in a business, it could be a scientific domain, engineering, many other areas. And when you put those together, you come up with, the traditional research of combining data with analysis and some domain experience. I think the hacking skills now is needed, added to these, because it's hard for anyone to analyze such volumes and complexities of data without an automated process or a system to scale that analysis up or down in some cases when we have the edge cases. So machine learning is something that we hear and it's very popular. Our program not just is concerned with machine learning, but the whole process of data science, from data ingestion and engineering and management of large volumes of data, together with analysis, machine learning, and communication parts of that process. Next, please. To apply that full data science process, we have a curriculum and a set of classes to match with that process. The main programming language we use throughout the program is Python. So in the first quarter, in the fall quarter, that's actually what we start with. Our students typically come with varying degrees of programming experience, from almost none to some experience or good amounts of experience in languages like Java, C, and others. And almost a majority of our students, even at the start, have some Python or scripting experience. So that's definitely something we expect you to have to be able to be successful even in the Python for data analysis course, because in that course, what we do is we combine existing programming skills with libraries and skills in Python that will help you to successfully go into the program with a solid background on ability to program. We have, along with that, in fall, a seminar course, case studies and data science course that starts. This is a course that runs through the whole year, and it's intended for our students to have experience and introductions to professionals working in data science. So through that course, our students get to see different uses of data science in professional life. and interesting examples of methods and case studies that use novel data science techniques. Following the fall quarter in the first year, we also, along with, in alignment with the program's name on data science and engineering, we start the foundational courses on data management and probability and statistics. So this is sort of the theme actually throughout the quarters. Typically, you'll have one data engineering related course and one more statistics and machine learning related course that follows with a machine learning course and a systems course that talks about scalable data analysis and big data. The second year in fall, data integration and beyond relational data models are the two courses. And in the winter quarter, we conclude with data visualization. These are the traditional courses in the program. Last 2 quarters, there's also a capstone course that runs that requires our students to group in numbers and 3 to 5 students in one group and work on a real life project with, not training data sets, but real data sets and real problems. And this is a very popular course by our students because you get to apply what you learn and add to those skills together with mentors who did not, necessarily teach in the program. So it's an opportunity to apply your skills and also add to those skills through mentorship of capstone project faculty advisors. Next, please. So Yvonne will talk to us about the admission guidelines at this point.
Thank you, okay. Yes, so back to our admissions guidelines. They're really similar to the Wireless Embedded Systems program, as well as the Architecture-Based Enterprise Engineering program, same kind of bachelor's degree. I do feel that the Data Science and Engineering program does have a bigger variety or diversity when it comes to bachelor's degrees. But, with it, engineering, science, physics, math is a preference, but not required. Again, the 3.0 minimum GPA is a university requirement, but we can work with you on that. As Stacy said, work experience is more relevant than GPA. We also have a statement of purpose that is required. And for this program, it's 2 letters of recommendation are required, but 3 is preferred. A resume, and then no GRE for this program as well. Again, if you have any questions about any of these admissions guidelines, I am here to help and answer your questions. In addition to the admissions guidelines, there are some additional guidelines with the Data Science and Engineering program. The application is a little bit different because it does have additional questions that are asked. I believe there's like 6 questions that asks just to give the admissions committee a little bit more of an idea of your experience with data science. So some of the major important things that they kind of look for is your programming experience. If you have any with C, Java, Python, any prior experience, both academic or, in your workplace, any experience with databases, SQL, and then experience with data analysis in an application domain. So these are some of the major things that they look for. Definitely not something that is required. If you have 2 of the 3, that's great. Some minor important things that'll help strengthen your application is a good math foundation. They're looking that you've taken linear algebra, they've taken probability and statistics. If you have any experience with distributed systems like Hadoop and Spark, those things will definitely help strengthen your application. So just a little bit more for the Data Science and Engineering program because we have those additional questions on the application. And then next steps for you all interested in applying to our programs. The next step is if you haven't checked out our website, that's definitely a good place to go for a lot of information about each of our programs. It also has application deadlines, contact information for us if you're looking to reach out to Stacy or I. But we also have our emails listed here on this slide. We are accepting applications now. We do have an application deadline of today, April 5th. But of course, we have another deadline in June, so do not panic if you don't have your application ready. We do review them after each deadline, so we will review all the applications we've received up to tonight at midnight. And then again, we'll review the other applications that come in for our next deadline, which is in June. Again, it's posted on our website. And if you have any questions, definitely do not hesitate to reach out to Stacy or I. So from there, we're now going to break out into breakout rooms. Let me activate them. Each room is designated to a program. So whichever program you're interested in, feel free to hop in, and the faculty directors will be there to answer your questions. Before you guys go in there, I want to thank you all for joining. You do not have to come back to the main room afterwards. Once you've gotten all your questions answered in the breakout rooms, you are more than welcome to leave. But if you do have additional questions for us, feel free to reach out via email or any other means that we have on our contact us page. I think our phone numbers are there, whatever you're comfortable with. But thank you for joining, and we'll see you in the breakout rooms.